Alright, this is going to be a review of Activity 3 from Thursday, September 3rd. This is going to be all 4 transformation types. We did a study guide today. A few students were saying they were having audio issues, so I'm going to go ahead and go through this again. Hopefully that audio is cleaned up this time, but since it's not over Zoom, we won't have that connection issue. So, question number 1, it was talking about a quadrilateral being rotated 90 degrees counterclockwise and then translated to the right. It was asking what line segment would be the same as line segment PQ. PQ is going to be located right here. If a shape is rotated 180 degrees, that effectively means that that shape is going to be turned and more or less reflected across the x-axis. In this case at least. So we take that shape and we visualize it being turned over and flipped. You can use that just by even just drawing it on a sticky note and then flipping it upside down. That's going to have the same effect. So my advice for you on this one is get a sticky note, get a sheet of paper, and just do a rough sketch of that image and then just rotate it 180 degrees. Doesn't even matter counterclockwise or clockwise, 180 is 180. So when you flip it, you can see where that shape is going to wind up at, and you can see what line is going to match up with what. So visualizing this shape being rotated about the origin 180 degrees, you can kind of visualize that this line would then suddenly be facing in this direction and would be oriented that way. There's only one line in this shape that's oriented in that direction, and that's WZ. We don't have to do any measuring, no need to break out a ruler. Our answer is going to be line ZW or WZ. For number 2, this is talking about a double reflection. A double reflection means this shape is going to be reflected first over the y-axis, so my new coordinates are going to be located at, let me see here, 3, -5 is going to be one of them. And you can kind of eyeball the rest of them to get you the same shape. That's the first reflection. My second reflection over the x-axis is going to be located right about here, I believe. So this is my new shape. That's where it is after a double reflection. The question is, what transformation will have the same effect? What is the same thing as taking a shape from that corner and putting it over in that quadrant? Scroll down and look at your answer choices. First option, rotating a triangle 180 degrees. As you saw from my example from question 1, if we have a triangle that's located down there and rotate 180 degrees, yeah, the triangle is now facing a different direction, just like it is here, and our triangle has moved quadrants diagonally, exactly like it has here. So far, A seems like the most reasonable option. B says 360 degrees. 360 degrees looks like this. It didn't change. 360 degrees is how I am oriented right now at the camera. Nothing has changed. The 2 other options are translations. The problem with translating a figure is it shouldn't look different. A translation of that triangle should look exactly the same as the original, just in a different spot. And that's not the case. So the answer is going to be A. For number 3, it shows this parallelogram and it says it is reflected across the y-axis. It wants to know what are the new coordinates. My advice, don't do all 4. Stick with 1 and see if you can eliminate some answers. Starting with L, -2, 4 is my original. So L prime reflected over the y-axis should end up at +2, +4. Well, let's see if that's an answer choice. L should be at 2, 4. Oh, hey, there's only one answer choice that works. We don't have to waste our time and bust our butts trying to find the other 3 coordinates. We can narrow it down and just get our answer after doing 1. For number 4, this is showing a dilation. It shows our original shape is the smaller one, and our bigger shape is the new one. So we know it's a positive dilation. We know our dilation is going to be larger than 1. Ask what the scale factor is. Well, first of all, we know right away it's not going to be 1/2 and it's not going to be 1/4. because our original shape is the smaller one. Easiest way to handle this is to, again, just look at one point and decide for yourself, has that shape been affected? Or how has that shape been affected? Our original shape P, point P, is going to be at 3, 1. And P prime is located at 6, 2. All right, what happened? What happened to go from our old shape, which is P, to our new shape, P prime? What happened? You had to multiply by 2. 3 times 2 is 6. 1 times 2, sorry, I think I said the wrong thing just there. I'm really thirsty and I am completely out of water. So we got 3 times 2 is 6. 1 times 2 is 2. Our scale factor is going to be 2. That's it for this one. No need to look at all 4 points. No need to do any measuring. All right, so for number 5, we have triangle PQR was reflected across the y-axis, resulting in the triangle below. All right, so we're not looking at original. We're looking at something that happened after a reflection over the y-axis. This is not the original. It's asking for what were the coordinates of the pre-image of point Q. So that's important. We are not looking at the original. This is Q prime. And this is after a reflection across the y-axis. So we're going to reverse it. That was reflected across the y-axis. We got to undo that. So point Q is located at -4, -3. Our original Q should be located at +4, -3 over here, equal distance from the line of reflection, which is our y-axis. So that new coordinate, +4, -3. Let's scroll down and find our option. +4, -3, right there. Number 6, it's asking how does an area of an image change when it's dilated to a scale factor of 2? For those of you who want to know the straightforward answer, it's going to do more than just double. I guarantee that's an answer choice. Let me double check. Yeah, 2 times, that is an answer choice. That's wrong. Here's why. When you dilate a figure by a scale factor of 2, what's happening? Every individual side of that shape is going to be doubled. Everything is going to be multiplied by 2. That means both the length is going to be multiplied by 2 and the height is going to be multiplied by 2. What that means is when I take this shape and I actually multiply everything by 2, that's wrong actually. Let me fix that. It should end right here. These would be my new coordinates, and this would be my new shape. The base of this shape is going to be 4, and the height of this shape is going to be 8. Whereas the original had a base of 2, and it had a height of 4. 2 times 4 is 8. 4 times 8, that's 32. It actually quadrupled. The reason being, you doubled the base, and you doubled the height. That's the same as doing times 2 times 2. It's more than just doubling. You double all of the sides that are multiplied to get the area. That means you're doubling the length, doubling the width. You're doing times 2 times 2. That's times 4. For number 7, it says this trapezoid is rotated 270 degrees clockwise about the origin. So this point R, is rotated 270 degrees. 90, 180, 270. Trapezoid should end up there. Let's go cross out all the answers that aren't double positives. So that can't be it, that can't be it. It's either A or B. So point R, my original coordinate was at +4, -1. So my original is 4, -1. Now, when you rotate 270 degrees clockwise about the origin, what you're going to do is switch your x and your y coordinate. So we got -1 now, and we got 4 over here. And then you have to reverse the first coordinate. So the first coordinate is a negative, make it a positive. We have now successfully reflected that point, or I keep saying reflected, don't know why, but can't be bothered to redo my recording. It's going to be +1, +4, which is going to be located right here. That should be the new coordinate. So +1, +4. Let me scroll down and choose that answer. Done. For number 8, this one's asking about a scale factor. It shows us 2 pictures, and it asks us what scale factor would have been used in order to take 3 centimeters and 12 centimeters and change it. For this, we went from 3 and we turned into 12. What did we do to that 3 to get 12? You multiplied. What did you multiply by? 3 times 2? No, that's 6. 3 times 3? No, that's 9. 3 times 4? That's 12. Got it. It's times 4. That's all there is to scale factors. For number 9, I didn't like the way that they phrased this question, but I'll go ahead and let you know what it meant. This said triangle ABC is translated into DEF. I hate that they did that. They should have done triangle ABC into triangle A prime, B prime, and C prime. Reason being, it tells us coordinate E is at the origin. Cool. What is E supposed to match up with? Does E match up with A? Does it match up with C? Does it match up with B? They kind of wanted you to make the inference that since both of them are in alphabetical order, that B would match up with E, since each one is the second coordinate mentioned in that set. But I don't like the way they do that. They should have called it A prime, B prime, C prime, but that's besides the point. What they meant was that E is supposed to match up with B. Now, it says that this point is where E is. And E, I'm just going to come out and say it, that should be B prime. How did we get there? What did we do to point B in order to get it where the new point is located? Well, it looks to me it probably would have been a translation. So, as a matter of fact, it does say translated. I just didn't read the problem so closely because I didn't do what I was supposed to do for this problem. Oops. This point, it's going to be translated. Let's count how far down. 1, 2. So it should be 3 coordinates down, and it should be 2 coordinates to the right. So let's see what happened. 3 units down, 2 units right. Perfect. We got the answer already. It's hard to make translation problems hard, but they try. Question 10. Triangle RST, it below, will be rotated 270 degrees counterclockwise about the origin. So for this one, so it wants the coordinates of S prime. If it's rotated 270 degrees counterclockwise, it should end up down here. So that recording cut out partway through, but again, too lazy, not going to re-record it. S should end up as a positive coordinate first, negative coordinate second, so we know it's not these two. S was supposed to be 4, +1. So 4, +1. My new coordinate is going to be located down here. Kind of the same thing as the last rotation problem, except this time, since it is counterclockwise, something is different. We are still going to switch the values. It's going to be 1 and 4. However, unlike the last problem, where it was rotated 270 degrees clockwise, since this one was counterclockwise, you're actually going to take the opposite of the new y coordinate. So it's my second value that is going to become a negative. So it's going to be 1, -4, like that. And that's honestly it for this study guide. I don't really have anything more to go over with this. In class, you guys seem like you were getting the hang of it, and I hope this video helps those of you who couldn't hear me too clearly in class. I know there were a lot of connection issues, so I hope this helps. Bye.